Time for us to get started. Mostly the same set of announcements, but there's one new one. We have an exam on Friday. We have an assignment due tonight. I'll have office hours after this class with regular questions about any of that. The TA is mostly through the first assignment and is hoping to release that to you all at some point this morning or early afternoon. I looked at the grades in progress and it did not look great. So before people freak out too much about the grades that you see, I anticipate just looking at that. What I'll be offering the class is the ability to redo it and resubmit it for full points. So if you're not happy with the grade that you have or that you see, don't worry too much. You will have a future opportunity to resubmit that and get it. I would rather people iterate on it and understand it, especially because this is a very important topic for the 8th, than just say too bad. So that will be coming. I wanted to ask if anyone has any clarification questions about the study guide. Tomorrow's class will be a full review session for the exam. So if anyone would like me to prepare any content for that, please send me an email with particular topics that you would like me to go over in more detail or that you would like practice problems with. Otherwise, we're restricted to what I can come up with off the top of my head, which I like to think I'm okay at that, but I don't like to completely rely on it if there's something that the entire class would like to get something out of. So let me know, and I will make tomorrow's class as useful as possible, given your feedback. But if people could come prepared with 4 or 5 questions, that would make sure that we don't run out of content. Otherwise, I will just be sitting here waiting for you to come up with questions, and it's very awkward. I don't mind that, but students tend to think, wait, why are we just sitting here staring at each other? This is awkward. All right, so today is the last day of new content before the exam, but remember that the only content that will be on the exam is that is on the study guide. So a lot of what we've done over the last week or so is off the scope of that because we have not gets to have an assignment about it and get feedback on it. I have requested the TA to grade the assignment that is due tonight as quickly as possible and get that turned around so that you have access to that as soon as possible.
How many questions are on the test?
I did just finish writing it this morning. I do not recall. I do remember that there are 104 total points, and it will be graded out of 100. And it will be a mix of describing concepts, not so much defining concepts, but describing how they work or are used, as well as some implementation. So do be prepared to write some code on the exam. As I mentioned before, I'm not a huge syntax stickler. I would like it to be approximately correct, but if you forget a semicolon somewhere, I'm not going to talk you half the points for it, or really any points for it. I care much more about the logic that's embedded in your solution. If an IDE would help you to be able to correct the mistake, the syntax mistake that I see, I'm not too concerned about it. I more so want to see, do you understand these concepts and can you work with the underlying logic to produce something that is logically correct? All right, last time we went over basic recursion. So we talked about recursion as a method that calls itself. When you have this, we need some way to terminate that recursion. Otherwise, it seems to look kind of like an infinite loop where you talk to yourself and then talk to yourself and then talk to yourself or call yourself and call yourself and call yourself and call yourself. So we need some way of getting closer to what we call a base case where we know the answer off the top of our heads. And then we do some logic as we go back up the recursive chain until we get an answer to the original question that was asked. So the way that we were looking at this was we were in a very long line and we wanted to figure out the position that we are in line. So to do this, we asked the person in front of us how many people are in front of you. When they turn around and tell us the number of people that are in front of them, we add 1 to that value, and that is the number of people in front of us. So we wanted to come up with some kind of way of talking about this and describing it in kind of some pseudocode. So I outlined this method that we were going to write called number of people in front. It takes a person object, so you would pass it us. And we have access to person in front, which is going to return whether or not a person is in front of that person. Get person in front returns the person object of the person in front. And then you can ask the person in front a question, and that question we're just going to assume is how many people are in front of you. So how could we actually turn this into code? Go ahead and find at least one other person to work with and see if you can come up with what would this look like? How can you put all of this together into a structure that's going to return this int, the number of people that are in front of us? By asking the people in front of us. Quiet in here. Talk to people around you.
Every time you call it again, there's no variability passed through, it's like the current count. Go ahead, relax.
In trouble getting started, it may help to just write this in pseudocode or in English first. What would the associated logic, if you were to kind of write this in pseudocode, look like? Yeah, we would want to be able to identify the base case, because we don't want to do any of the other logic if we are in the base case. So how could we do that? What would the base case look like? Does the what
Method return.
I guess, yeah, to return the integer, basically, I don't know, it's the ability to ask them. Can I go with this up top like that?
Are we somewhere like storing the total count or like passing it to the next method? Cause like,
Yeah, we probably don't even need the ask method. I'm looking at it now. We don't even really need it. It's gonna be modeled by the get person in front and then calling number of people in front of get person in front. So let's identify that base case. Let's figure that out together. So we need to identify whether we are in the base case. So that's a yes or no question, which tells us that this is probably some kind of conditional. If statement is true, then we're in the base case, otherwise we're in a recursive case. So how do we identify that we are in the base case? And obviously all of this logic is gonna go inside of here. Yeah,
I think in this particular case, it's if the Boolean function returns false.
yeah, so if there's no person in front, then we are in the base case. I love it. So if not person in front. And then we need some way to say basically me. And it's gonna take some kind of person. So if there's not a person in front of the current person, we'll assume that maybe, since we asked number of people in front for person P, we can say P here. Because that makes a lot of sense. If we pass in the person object for which we are querying, then we want to ask the person in front of this same person. Is there a person in front of this current person? If there is nobody in front of this person, what do we want to do? Return 0, there's nobody in front of me? I like it. Great, that'll identify the case of we are the first person in line. If this is not true, then we must be in a recursive case. So how do we want to figure out how to deal with the recursive case?
Like a while loop, person from person B, cycle forward, and then the count each time and set the further.
You would be able to do that if we were doing this iteratively. We're going to try to do this recursively, where we don't want to loop, we want to call this same method instead and just pass in a different person.
We could do, else return 1 plus a number of people in front. And then we could put in the argument, get person in front.
We want to return, there's an extra person here. And we need some way to determine, we now know there's a person in front, because otherwise this would have triggered. So we need to get that person in front and pass it into the number of people in front. So we're going to return the number of people, I don't know, I named this so long, in front. We're going to call this same method, but now we need to identify the person who is in front. So we need to get person in front. Get person. I guess this should really also take the person, get the person in front of the person that is passed in. So we could do something like this. Do we see how this kind of works like a loop? This is kind of a complex statement that we could also break up into multiple lines. But you can imagine, get person in front returns a person object. We want to know the number of people in front of the person in front of P. And then the number of people in front of us is that person who's in front of us, plus the number of people who were in front of that person. But note that number of people in front is the name of the same function that we're defining right here. So we're calling ourselves. Thus the recursion. Each time we call this function, there's gonna be one fewer person in front, and eventually we're gonna get down to this base case. So if there were 3 people in line, and I'm the last person in line, there are 2 people in front of me. We would have this person, me. So if we were to highlight exactly what's happening inside of this function, we would say, okay, I'm very curious about the number of people in front of me. Is there no person in front of me? No, there is not no person in front of me, so we're going to skip the if statement. We're going to come down to the recursive case. And we are going to get the person in front of me, which is going to return this person. And we're going to ask this person, how many people are in front of you? In order to answer this, we have to put this whole logic on pause. We're just going to say, all right, we're in the middle of this. We'll come back to it eventually. In the meantime, we have a new question to ask. And from this person's perspective, how many people are in front of them? So now from this person's perspective, is there no person in front of them? No, there is no person there's not no person in front of them. We're going to skip the if statement. We're going to return 1 plus the number of people in front. So we're going to get the person in front of them and ask them, number of people in front of them. We're going to put this logic on pause right here, and we're going to start a new version of this method, dealing with this person as the person object that we are passing in. Is there no person in front of this person? Yes. So we come inside the if statement, we return 0. So we're going to end the method that's associated with this person, returning this number 0. And now from this person's call's perspective, they see this whole thing resolved to 0. So they are going to turn around and report 1 plus 0 as the answer to their subproblem. So they turn around to me and say, this is now 1. So my logic now, as me, is going to say the person in front of me turned around and told me there was 1 person in front of them. So the number of people who are in front of me is 1 plus that. So I return 2, knowing that there are 2 people in front of me. So that's how it all comes together. In a way where we have the code, we are now able to kind of emulate the concept of a loop with no loop. We did an iterative thing where we had a person ask a person, ask a person, and we got back some answer, and we were able to answer a question using recursion. Does anyone have any questions about this code? Why this code answers this question? Any of the logic associated with following this line by line, step by step?
The advantage of this or allow this just that much more efficient.
It's actually not usually more efficient, but there are some problems where there's a significantly more elegant solution to a recursive problem than there is to using iteration.
It's like a readability thing.
One other thing is there's an entire class of programming languages out there called functional languages that do not support iteration at all. And so anytime you would want to iterate, you actually have to phrase it in terms of recursion. And this becomes necessary because it supports things like functions taking functions as parameters, functions returning functions rather than primitive variables or objects. So when you have functions that take functions, it turns out that you can do a lot with recursion. You can do everything that you could do with a loop, but in some ways it's shorter, simpler, and you can do things like list processing, for instance, as a very recursive type of thing. And we'll see some more examples of that as we go through some more examples, but there are also some additional things that we need to keep track of with recursion and think about with recursion that we didn't really have to think about with loop. that's coming to? Great question, though. Any other questions about this? Excellent. Now we're gonna write actual code that does actual things. It's not just kind of the toy problem of querying people in front of us. We know how to calculate a factorial, right? The factorial function can, of course, be written recursively in addition to iteratively. So let's start by just writing an iterative factorial. So we're gonna write a method that returns an integer and takes an integer. Int factorial that takes an integer n. Go ahead and in pairs, write a factorial function that whatever n happens to be returns the factorial of n. So if I pass 5, it should return 120. If I pass 3, it should return 6. So the idea would be if this is past 5, n equals 5, then return 5 times 4 times 3 times 2 times 1. And do this using a loop. Like this. Start a product out at 1, start I out at n, continue while it is greater than or equal to 1. Subtract 1 each time around, just multiply product by I. This will multiply 1 times n minus 1 times n minus 2 times n minus 3 all the way down to 1. At the very end of that loop, we want to return the product. Should solve factorial for us. Let's start thinking about how to do this recursively. So this is an iterative solution to factorial. Let's think about a recursive solution. So think about the base case. What's a factorial that we just know off the top of our heads, where no calculation is necessary, and every factorial uses this value? Yeah, 1 factorial, right? Everything is going to eventually break down into this times 1 at the very end. So we could identify this as our base case. We always know that 1 factorial equals 1. No calculation is necessary, we just know this. How could we phrase 2 factorial in terms of 1 factorial?
You ask that one more time?
How could we phrase 2 factorial in terms of 1 factorial? So we would have something like 2 factorial equals 2 times 1 factorial. How could we phrase 3 factorial in terms of 2 factorial? Yeah, so 3 factorial is 3 times 2 factorial. Would this extend to something like n factorial? How could we phrase n factorial in terms of n minus 1 factorial?
N times n minus 1 factorial.
Yeah, n factorial equals n times n minus 1 factorial. So this is the progression that we're going to use with regards to recursion. We are now phrasing a problem in terms of a smaller problem that has the same name as this problem. We're using the same factorial function, but we've made our factorial slightly smaller and closer to 1 factorial that we know the answer to off the top of our heads. So 1 factorial equals 1. We have 2 factorial phrased in terms of 1 factorial, 3 factorial phrased in terms of 2 factorial. Now work in groups and see if you can come up with a recursive factorial method. So rewrite int fact, int n, but now make it recursive, which means there will be no loop. And there will be a call to the factorial method inside of the factorial method in a way that emulates this logic.
Yes.
All right, now we have the iterative idea in code. So we don't need to have board anymore. So how are we gonna do this? Let's start us off.
I start with the. I start with the base case, so I did if n equals 1, return n, and then else. Return n times factorial n minus 1.
Yeah, we can return one, return n here, doesn't really matter which. But if we're not in the base case, so we first need to identify the base case. This is gonna be a general way you want to structure your recursive functions. You first want to check if you're in the base case. Because this return at the end is gonna kill the method. So we don't need an else anywhere here. We can just start writing the logic of the recursive case. If n is 1, we return 1, the method is over. There's no way we're checking anything that comes after this. So that represents the base case. Now we need to figure out, okay, how are we going to calculate the recursive case? So we want to basically say return n times factorial recursive n minus 1.
We also check in the base case for 0, it makes some sense.
Yeah, if we wanted to identify that 0 is that 0 factorial is also 1. So you could say if n is 0 or n is 1, and that would allow us to call our factorial recursive on 0 as well. And that's true in our iterative as well. So if we pass in 0 here, we set a product to 1, this loop will never run and return 1. And that way 0 factorial is also 1 in our iterative version. So we could absolutely do that. Is this what other people got? Note that it's surprisingly simple for something that might be as complex to wrap your mind around as recursion. The actual code, when you go to write it, is actually quite simple and straightforward. Once the logic of the idea starts to sink in, writing the code isn't too bad. We could test this to make sure they give the same values. So we could print out call this factorial iterative. Factorial. And we could say recursive. And hopefully when we run this, we get the same value. Looks like we have something going infinitely. What's the issue?
You have n greater than or equal to 1.
What, I greater than or equal to 1, don't we? And 5 factorial is 120. So it looks like both of these work. They weren't super slow. They both seem to run at about the same amount of time. So we're gonna stop with this for the moment. And just think that maybe these are reasonably equivalent and we'll come upon some reasons why they might not be. All right, so now we have an iterative and a recursive version right next to each other. Let's take a look at the next example. Fibonacci sequence. Who has seen the Fibonacci sequence before? Lots of people. So the Fibonacci sequence is, we define the first two values to be 0 and 1, and every subsequent version is going to be the sum of the two prior values in the sequence. So the next sequence is 0 plus 1, which is 1. The next one is 1 plus 1, which is 2. The next one is 1 plus 2, which is 3. So we start with 0 and 1. We sum these to get 1. We sum these to get 2. We sum these to get 3. We sum these to get 5. We just look at the past two values of the sequence. Thoughts? Can we write this recursively? Maybe? This looks a little bit different than our factorial, right? We have kind of two base cases and it seems strange. This can absolutely be written recursively. What would a base case be? Yeah, we would need multiple base cases. So we're going to identify Fibonacci of 0 is 0. Fibonacci of 1 is 1. Fibonacci of anything larger than that is going to be Fibonacci of n minus 2 plus Fibonacci of n minus 1. So we have two different calls to the same function, both of which need to be resolved in order to know the answer to our problem. So with the remainder of class, let's start out by writing an iterative version of this. Just go ahead and write out an iterative version of Fibonacci. So use a loop, work in groups, have an iterative version that you can use. Something like this. Think this will work? Anyone see any flaws? This, I believe, will iteratively give us the correct Fibonacci. If it's 0, return 0. If it's 1, return 1. Otherwise, starting with Fibonacci number 2, we're going to calculate the current Fibonacci number as the last 2 that we saw. And then in preparation for the next pass of the loop, we're going to update the 1 before and 2 before so that we're ready to calculate the new current. By the time we are done, current is going to store the current Fibonacci sequence number.
So we reduce it down to base case, except like if n is less than or equal to 1.
Return n. Yep, you could absolutely do that. In fact, I like that a lot. Less than or equal to 1, return n. Gets rid of the need for all of this. All right, let's start thinking recursively. So I like to be able to compare the iterative version to the recursive version, just so that people can see the difference in the logic as you construct one or the other. This one is probably fairly familiar to you, or the way of thinking for this is probably fairly familiar. It's nice to have a tie back to something that is familiar as you are learning something that is unfamiliar. What is the base case? We were trying to do this recursively. Yeah, we kind of actually have it baked in right here, right? So we could just borrow this logic and say, if n is less than or equal to 1, return it. It doesn't really make sense to call Fibonacci on a negative number, although I believe it actually is defined. We won't worry about that. We'll just assume this only works for positive values at 0. That would take care of a base case. What about the recursive case?
And minus 1.
That sure seems a lot simpler than the iterative logic that we were doing. There were a lot of ways that we could mess up the iteration here and making sure that each variable that we care about has the associated values that we also care about, that the updates there are happening correctly. And this looks more like the definition of Fibonacci. It looks like we're using the definition of the Fibonacci sequence to calculate the nth Fibonacci number, which makes your code a little bit more readable. We can again write a tester, just like we did for this. So let's just grab this whole method and change a couple of names. I also realized this class is not capitalized, and it should be. Fibonacci iterative and Fibonacci recursive. Looks like the fifth Fibonacci number is 5, 0, 1, 1, 2, 3. Looks like we're counting the zero as the 0th Fibonacci number, because then the next one would be 5. That's probably fine. 0 is the 0, 1 is the first. So we have 0, 1, 1, 2, 3, 5. I buy it. What is the 10th Fibonacci number? What is the 20th Fibonacci number? Anyone see anything to discuss? Not too bad. Uh-oh, it looks like our recursive version is starting to take a little bit longer. You overflowed the integer, which is nice. Our recursive one, unfortunately, is not really finishing at a reasonable period of time. Can anyone take a guess as to why this is? Why is our recursive version struggling with this?
Well, every time you call it, it calls itself twice instead of how factorial called itself once.
Yeah, we're gonna come back to this next week, and we're going to explore a lot more of why this recursive version is taking so long, as well as one of the big issues that we can run into when we have a, hey, look, it finished. I was not expecting it to finish. Modern machines are very impressive, but we'll actually look at the why. We are out of time. Hopefully this was informative. Iterative would be fine. We can do this with logs, and we can actually see that it works very nicely for the iterative. Recursive, not finishing. In fact, it probably wouldn't finish in our lifetimes. Oh, yeah. I responded to your email. That email, so he should have received that. So I think he's in his queue right now. Yeah. So maybe we'll see. Yeah. Someday I'll bring that my attention.
I mean, I forgot to put the ball on the circular one, like I didn't even, it is. Like, I believe you have to do that.
I'm just.